Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about 1814 count nice pairs in an array. You are given an array nums that consists of non-negative integers. Let us define the reverse of x as the reverse of a non-negative integer x. For example, reverse of 123 is equal to 321 and the reverse of 120 is 21. No leading zeros are allowed, right? Okay, a pair of integers I and j is nice if it satisfies all the conditions. Okay, I and j should be inside the range of 0 and nums of length. Okay, fine. And I is less than j. That means what? I and j should be a unique elements, not the same elements. Okay. Now, nums of I plus reverse of nums of j is equal to nums of j plus reverse of nums of I. That's it. So these are the two conditions, and we want to return the number of nice pairs of these indices, not the pairs. We don't want the pairs value. We just want the pairs count. That's it. And if it is too large, just mod with 10 power 9 plus 7. So it is not a case. Okay, it's simple. Okay, fine. Let us understand the question. See here, this is the first example. Okay, in first example, they have given that 42, 11, 97, and 1. Okay, now from here, what are the nice pairs? Okay, I can say this 42 and 97 are nice pair because when I am doing 42 and the reverse of 97 is what? 79, and 97 plus reverse of 42 is what? 24 is equal to what? Here also 121, here also 121. So it is matching, right? So it is the one of the pair. Okay, so 1. Okay, now the second pair is 11 plus 1 is equal to 11 plus 1 is equal to 1 plus 11. Okay, when I am applying in this formula. Fine. So here also 12, here also 12. So this also one pair. So totally how many pairs are there? Totally 2 pairs are present in this array. Fine. So what is the brute force approach? So brute force approach is very simple, right? Just go and iterate. Okay. First take this as our I and take this as our j and check whether this is following this condition. Okay, if not, then move here, then move here. Okay, again back, come to here, then move here and check whether this 11 and 97 is a nice pair. No. Then 11 and 1 is a nice pair. Yes. So we'll increment our count as 1. Yes. Now again I will move to this 97, then I will check whether 97 and this 1 is a nice pair. No, it is not a nice pair. Again I will move to this 1, there is no elements, so I will stop it. So totally there are two pairs. One is 42 and 97, another one is this 11 and this one. That's it. Okay, so this is a brute force approach. And what is the time complexity of this brute force approach? It is over n square, because we are just traversing the array with one element for entire array, right? Okay, now what is the space complexity? It is over 1. So this is a brute force approach. Okay, whether we can optimize this approach. Okay, how to optimize this approach? Okay, whenever we are learning some like in math algebraic expression, we just take this and move this expression to the RHS and LHS like that, right? So same technique is going to apply here also, because it is a math problem. Okay, so see here, let me take this nums of I. Okay, and instead see here we want what? Here I want I and j. Here also I want what? J and I. So don't only we want 2 pointers, right? Okay, instead of that I am going to make one RHS as a same variable, like nums of I minus reverse of nums of I. I will take this term and move here. So minus reverse of nums of I. Okay, when this expression is equal to what is the next expression? I will take this reverse of nums of j and move here. So when I move here, it will be nums of j minus reverse of nums of j. Now see here, in RHS, in my RHS side, all are what? Sorry, in my LHS side, all are what? I variable, and in my RHS side, it is all are j variable. Now understand this. Now whenever we are taking the count, if the count are same, it will make a pair. Okay, now let us take an example. See here, this is the example. Okay, now Now come here. First of all, take a hash map to count the values. Okay, right. Now first of all, take this 13. Okay, 13 minus here nums of I, right? Minus reverse of nums of I. So minus 31. So which is equal to what? Minus 18, right? So take minus 18 and make it as count as 1. Okay, fine. Now then come here, it will be 10. Again, minus reverse of 10 is what? 1. Okay, it will be 9. So 9, make it as count as 1. Okay, now again 35. So 35 minus 53. So what is 35 minus 53? 35 minus 53. So it is also minus 18, right? It is also minus 18. So make this minus 18 count as 2. Okay, now again come here, it will be what? 24. 24 minus 42. So 24 minus 42. It is also minus 18. So make the count as 3. Okay, now again come to 76. 76 minus 67. So 76 minus 67. So it will be 9. Okay, and make this 9 count as 2. Now listen this carefully. Listen this carefully. There are two values. There are two values that leads to what? 9, and there are three values that leads to what? Minus 18. Now listen this carefully. This is the math problem basis. There are many problems that behaves like this also. Okay, see here. If they are asking a pair, then I can take this and make this as one pair, right? Again come here. I can make these two as one pair, and again these two as another pair, right? So again I can take this one and this one as another pair. Okay, so totally how many? What is the answer? It is 4. Okay, in simpler way, if there are 3 minus 18, okay, just tell me, by using this minus 18, how many pair I can make? I can make this as one pair and this as one pair, so 2. Okay, fine. By using this 18, how many pairs I can make it? I cannot make this because they have strictly given that I should be less than j, right? Okay, this is I, then I can make only one pair, so plus 2 plus 1, so it's equal to 3. That's why we are getting 3. Okay, so if take for example, if I have a number like 1 1 1 1 1 1 5 times, then by using this one I can make 4 pairs. By using this one I can make 3 pairs. By using this one I can make 2 pairs. By using this one I can make 1 pair, and by using this one I can make 0 pair, right? Okay, so this is like what? This is like n natural number sum, right? Sum of n natural number. But see here, how many ones are there? Totally 5 ones are there, but we are just going up to what? 4 only. So it will be sum of n minus 1 natural number. So what is the formula for sum of n natural number? It will be n into n plus 1 divided by 2. But here we are just taking what? N minus 1. So n minus 1 means n minus 1 into n divided by 2, right? Because here it will be what? N minus 1 plus 1, and this plus 1 minus 1 will cancel. That's why we are just taking what? N alone, right? So the formula is n into n minus 1 divided by 2. If I having like 4, then here it will be 3, then here it will be what? 4, and this 2 and this will cancel and get 2. Now 2 into 3 is equal to 6. If I have 3, then I will get what? 3. I will get 3 only. Now let us see the coding part. So see here, in coding part they have already given that we want to mod 10 power 9 plus 7 at the end. So I am just declaring it in a mod. Now for a reverse function, I am just writing a reverse function. Here temporary is equal to n and result is equal to 0, while temp rem is equal to temp mod 10, then result is equal to temp star 10 plus rem. Okay, now temp is equal to temp divided by 10. Now return the result. So here we don't want to use this temp also. You can also use the n alone. Okay, that's your wish. I am just taking this temporary variable. Okay, and I am reversing it. Okay, reversing a number is easy, right? If you don't know, I will give the link in the description. Just go and watch that video also. I also have that video. Okay, now I am having a hash map for the counting purpose. Okay, now this is a formula, right? This is a formula I mentioned in the drawing explanation also. Okay, now for I in nums, val is equal to I minus reverse of I. So this is the purpose of making the LHS or RHS as the same variable. Okay, now if val not in D, then I will declare it as 0, and as usual I will do +1. I am incrementing the vals count. That's it. Now result is equal to 0 for I in D values, and I am applying the formula, that n-1 natural number sums formula. Okay, and I am adding in the result. Then last I am returning the result mod is what? 10 power 9 plus 7. Okay, so this is what the code, and let us see what is the time complexity for this code. Okay, just analyze. See here, we are using a reverse, right? For reverse it takes what? Log n base 10. Okay, and we are using what? A dictionary. So dictionary will take log n base 2, and this traversal will take what? Up to n. Okay, so totally what is the time complexity? So let me write here. Time complexity we got O of n log n in total. Okay, now what is space complexity? It will be O of n, because we are taking what? The hash map, and this log n created by the hash map, and for reversing it is log n base 10, that is lesser than the log n base 2, right? So this is the time and space complexity analysis. Thank you.